Hello. Yes sir. अ, अभी कंप्यूटेशनल फिजिक्स वाले भी है क्या इसमें?
Yes, sir.
ओके ओके so let's take the attendance then because your the computational physics names may be not here, so I'll ask you to send me someone. Please send me a, a list of the students in Excel sheet, so it will be easy for me to include them.
Yes, sir. I'll just send it to you.
Okay, thank you. So, uh, Alok, Alok Kumar Mohan, here. Anjana, Asghar Ali,
Yes, sir.
Atul, Brahma,
Present, sir.
Abdul, Dia, Sita,
Present, sir.
Kalpana,
Present, sir.
Kiran,
Present, sir.
Kuldeep,
Present, sir.
Magan,
Present, sir.
Murli,
Present, sir.
Namita, Naveen,
Present, sir.
Rohit, Roshan, Sagar, Sarang,
Present, sir.
Simple,
Present, sir.
Saurav, Prabha,
Sir, Saurabh Panchal present, sir.
Arshita, Rituparna,
Present, sir.
Samarkand,
Present, sir.
Satish,
Yes, sir. Present.
Shweta,
Present, sir.
Mushri,
Present, sir.
Thiru, Tiruvedi, Rahul,
Present, sir.
Vinod,
Present, sir.
Yogesh, Deepika,
Present, sir.
Virendra,
Present, sir.
Sir, Anjana present.
Okay, so
Sir, I've sent you the list on WhatsApp.
yes, yes. Just a minute. So only these 15, 16 students, right?
Yes, sir. 15 students.
Okay. Okay, so because Didhi, China,
Yes, sir.
Rupesh,
Present, sir.
uh, Abhinand,
Present, sir.
Athira,
Present, sir.
Kabir,
Present, sir.
Mukesh,
Present, sir.
Kaivalya Prasad,
Present, sir.
Arshita, Harita,
Present, sir.
Shiva, Ganesh,
Present, sir.
Arpit,
Sir.
Anuja. Okay, सबका हो गया ठीक है. Okay, so for the new
Hello.
students, yes,
Yes, sir. I'm Vidhi Thomas, sir. I'm present.
okay.
Yes, sir.
Anyone left from this new list? I think everyone is here. Okay. Okay, so for the new students, we have already taken some, I think 3-4 classes on this Fourier series topic. So this is, as you know, this advanced physics 1. We have this mathematical physics, the advanced part, like the transformation and differential equation. So this will be one part, and another part is the classical mechanics or related classical mechanics, which will be taken care of by Kamlesh sir. Okay, so I have shared one assignment, so which is actually based on this Fourier series, and you will find that some topics which are all not covered yet, but I have given that is from the entire Fourier series, so you can slowly do it by the time we cover all the topics. Okay, so you submit it after just exam, so no problem. Okay. And one more thing, so if anyone from the computational physics, if you are interested or if you are good in programming, then so maybe I'll share it in the this group also. So there is one PhD position, so it will start maybe somewhere in July, August. So if you are interested in programming, you may apply actually for that. It's in Prague. So I shared with physics group, but not in this group. So computational physics students, if anyone is interested in programming, or if you are already expert in programming, so you may look into that position if you are interested. Okay, so I will share it in the group, and you may let me know if anyone is interested. That is also there, that I can help in some. I can share some of the details of the project, what is all about in this project. Okay, so that's an announcement. Okay, so now I will give you a brief of whatever we have done so far. It's not, I think, for the computational physics. So you have already gone through this Fourier series course, I think, right, in the mathematical physics in your first year or something like that, first year or first semester.
Yes, sir.
Yes, yes, because the syllabus is bit different from what you means, you have already done this, but you have to do it again, because in our syllabus it was not there in the first year mathematical physics. Okay, so so then it's good for you, so that you don't have to so I don't have to repeat again all the basics and all. So we can just start.
So we don't
where-
mind doing it again also.
Sorry. Okay, I can remind. Okay, okay.
We
So
don't mind, yeah.
okay, okay. So anyway, so I will start from where we left. Otherwise, because anyway, once in a week, so the class is not moving actually. So I will start from what we left actually in our regular class, because anyway you can take it up. Okay, so we discussed about the Fourier series and the Fourier series having discontinuities, and we discussed that at the discontinuous point, let's say you have, so skin is visible, right? I have shared already, I think.
Yes, sir.
Yes, yes, yes. Okay, so let's say you have a periodic function. So this is x, this is f of x. So you have a periodic function, and let's say this function has a discontinuity at this point, some point. We called it as a C0, I think, in the last class. Anyway, so at this point, if there is a discontinuity, so then this is a your periodic function, because it follows your Dirichlet condition. So then at this point, the function may not be defined. For example, I have a function. So any function, actually you can do it yourself to make it periodic, because you can define a well-behaved function and make it uh, something like that. Because in the assignment, most of the problems you will find that those are actually may not be found in a book. Most of some maybe you can find, but some are actually I have just formulated. So if you find any difficulties in solving those problems, let's say you are not getting any solution, so let me know, because maybe I have missed something, because I formulated by myself. So maybe I have done some mistake when I am formulating those mathematics. Okay. So, and some of are from the previous year questions. So it's a mixer. So let's say you have, so this function I have defined in the minus pi to pi in a, so this is similar to some function which is defined in this region. So let's say this is a function which is defined like this, right? So this function has a discontinuity at this point. So you can see that at this point this function is not continuous according to this definition. So so the problem will be uh, so the problem will be how can I find it? Because you know that the Fourier series f of x is nothing but a0 by 2 plus summation an cos nx, this is n0 to infinity, plus summation bn sin nx. So this is also n1 to infinity. So this is your Fourier series. Okay, but this discontinuous point, this series does not know actually, because there is nowhere if you put these values it will tell you the value at x equal to 0. But anyway, we never said that x is not possible or 0 is not possible in this Fourier series. So this is a continuous series, seems like, because these functions are continuous, sin x, cosine x, even this constant, anyway this is a constant term. So these terms are nowhere this discontinuity is written, or it is given or explicitly said in this case. So if you put f is equal to 0, what will happen? What will happen to this series, right? So this series has to give you some value, but in the actual series, then what will be the value of f of 0 in this Fourier series? Although from the basic definition of this function, so this is defined in one period, but this function will be everywhere, right? It's a periodic function, so all the periods are involved here. So everywhere you can get the value, including these zeros. So what will be the value? So that actually the Dirichlet theorem, or Dirichlet from the Dirichlet condition and the Dirichlet theorem. So that actually says that the value of f0 will be, so we already discussed, that will be average of these two values, that you approach from this direction and then take the values, and then take the value and sum it and then half of it. That means it is kind of average of this and this value, because if you come from this side, you will encounter this as a value at x is equal to 0. If you coming from this side, then you will encounter this as a value of function at x is equal to 0. So you are getting these two different values if you are approaching from two different sides, right? So now the theorem says that you just take the two values and make it half. That means according to this Dirichlet theorem, you will get the value at the average or the midpoint. So it will be, in this case, it will be, our value will be, so in this example, the value will be, so it is like if you are coming from, so if you are coming from, let's say, from negative side, so I'll say that so for this case, what is happening, that you are coming from, let's say, from the 0 side, so it is from the negative side plus 0 from the plus side, and then take it, and then, so that means if you are coming from negative side and approach to 0, your value is minus 5, and this is from 0, it is 0, so your value will be minus pi by 2. In this case, f is equal to 0 will converge to minus pi by 2. That means this series will converge at x is equal to 0 to minus pi by 2. Okay, so that we will see with this example when I discuss this example. So this is already we discussed in the last class. Now, so with this example, if I draw this figure, this Fourier series. Solution means you know that in this Fourier series is nothing but you have written your function in a basis, and the basis is sine and cosine. So these are uh, also known as sinusoidal basis. So this is cosine. So this is your basis, and this is your basis. So this is our basis function actually, sine and cosine functions, and then your aim is to find this unknown, because this is deciding your actual function. So how we will find an, or rather I will start from 0. So what is a0 in this case? Finding or using a vector, like, so this is nothing but your average value of your function. So this is f of dx. So these things are very important things to remember, that what is the physical meaning of a0, and bn, right? We discussed already. Anyway, so this is the value. So if you do this integration, so you will get it minus pi by 2. So, or rather let's do it for once. So what I will do it, so this function is defined in two intervals. So minus pi to 0, f of dx plus 1 by pi, 0 to pi, f of x dx. So these two function values in these two range, you know it, right, from this definition. So if I put all this value, you'll get it minus pi by 2. So this I'm not going to do. So this is a0. Similarly, you can find an. So this is in the same manner. I'm not going to do it. I'll just write it. So, but be very careful, because in some competitive exams, the Fourier series may be written in some other basis. Other basis means I can interchange the n, bn, or something else, like some other way. But you have to be careful that what is actually defined in that uh, series, or how the series is defined. Then only you can find it. So according to this definition, my an is 1 by pi minus pi to pi fx cos nx dx. So this is, so if I solve it using this function, you will get is 1 pi n square cos n pi minus 1. So this is the value of an. Now now what is the value of bn? So from this definition, my value of bn minus pi to pi, and one thing always remember is that minus pi to pi are 0 to 2 pi, the things are same actually. The how you write is that, because every entire thing you can shift to that 0 to pi range, right? But interval must be 0 to must be 2 pi. That is the condition also from the Dirichlet condition to write it in a Fourier series. Okay, so those conditions are important. Okay, so if I do it for an, so it's fx sine nx dx. So what will happen? So you will get 1 by n, 1 minus 2 cos n pi. So this is your an, bn, and a0. Now, if I put all these in that series, then what will happen? Okay, so if I put all this, then I will get two series. Okay, so if I put all this in that Fourier series, then I can get the actual series, right? So remove, so let's remove this part so that I can get a space on the top. So fx is nothing but a0 by 2, that is pi by 4 plus you have this an cos nx plus bn sin nx. So also I discussed, just to remind, that this, what is the meaning of this nx, right? So this is increasing, right? And this is nothing but your, it will somehow correspond to your frequency in your in your uh, in your spectrum, or in your series. Different frequencies are present, it means, and those are actually also known as nodes or harmonics, actually, not node, harmonics. So maybe I'll see if I can take one example in sound, then these things are more prominent, this harmonics and all. Okay, this minus pi by 4 plus, I will put all the values whatever we uh, obtained. So this is 1 by, so these values I will put it here, and pi square into cos n pi minus 1, then cos nx. So this is the constant and this is your basis function. Similarly, I can write it for b, and I can remove this part. So plus, this is your bn. Bn is this term, right? This is 1 to infinity 1 by n 1 minus 2 cos n pi sin n pi, sorry, sin nx. So this is your basis nx. I can remove this now. Okay, so now from here I can uh, see something, actually. Cos n pi is equal to 1 for n is even, from this analysis. So cos n pi, and it is minus 1 is n is odd. So depending on that, this series will this series will be affected. So if it is 1, that means it will be 0. So that means 1 will not exist in this series, right? So the 1 I shouldn't get. Sorry, even means 2. Sorry, 2, 4, 6. These numbers will not exist. So this n value here, 2, 4, 6 will be 0, because if it is even it is 1. So this 1 and this is 1. So this term will be 0. So with this condition, cos 3x, all this term will exist. This is okay for this term actually. So far we have written this term. Now come to this term. So same thing will apply. Then what will happen? So here, depending on the values, it will have different values. So I'll write it like this. So it will come as 3 sine x. You just expand this using these values. Sine x minus sine 2x by 2 plus 3 sine 3x by 3 minus something like that. So this will be a sine series and this is a cosine series. Now I'll remove this. I'll remove this part as well. Now we put x is equal to 0. What will happen? Because in this series, no one is said that if x is equal to 0, what will happen, right? But who has said is that Dirichlet. So he said, so according to that condition or that theorem, it says that f of 0 will be minus pi by 2. Just we calculated, right? So according to this theorem, so that means this series at x equal to 0 should converge to minus pi by 2. If it is that, then what we are getting, minus pi by 4. See, if assign 0, all this term will be 0 and cos 0 will be 1. So that means I can get 2 by pi cos 0 1 plus 1 by 3 square. See it. So this, that means here using this you can actually calculate is that this will tell you formula is that you can write 1 plus 3 square plus, that means this will be 5 square, is equal to do a rearrangement, you will get pi square by 8. So this series, this series you can get. Now this is for this 1 plus 1 by 3 square plus 1 by 5 square plus this. You can see, you can check whether you get this, the value of this series equivalent to pi square by 8. Then you know that whatever Dirichlet theorem says is correct. So in other cases also, you will find that what is the value of this series. Okay, so this is the things for non if the function is not continuous or discontinuous. So then your function can give you or you can calculate the function value using that condition, and according to that your series will converge to that, and that's why we don't have any issue, although this looks very continuous things. And then if you put all this value, because if you put all this value in your computer, so it should, and at the infinite number it should give you exactly this curve, right, or close to this curve. If it is infinite, then it will be exact, but with large number you should get close to this curve. So this, if you put all the values of x, like all the component like cos x, cos 3x, cos 4x, 5x, 6x, 7x, all the series, like n is equal to, let's say, 100 or something like that, then you put all the value and plot each and this, because you can plot this, or and then you can take the summation also of all these terms, and then you can plot it in this region minus pi to pi with fx and this component. Then what you should get, you should get exactly this function. But you'll see that here you have a so the things will have transition here. Maybe I'll so if you really want to visualize this, you can actually check the book by ML Boas, and also you can write it your own program also. I also have I written a program on this. I can maybe I'll share it if you want to use it. Okay, so or you can check the actually figure 6.2 in ML Boas book. So ML Boas book figure 6.2. This figure actually tells you about this fact that if you increase the number of n, then at some n you will reach this kind of function, because actual function is like this, and that will happen for a large value of n, not for small values, right? And then what happened to this point for those values? So you can actually go to this figure and see what exactly happening. Okay, so that is kind of example in that book. Okay, so now come to the another thing in this direction is that if so this is your function is defined within this entire region, like minus pi to pi, within the interval of 2 pi. But let's say if your function is not defined within this interval, so for example, let's say your function is defined within this interval only. So I'll remove this part, I'll leave that part maybe. So in this part, let's say your function is defined within this interval 0 to pi, it is defined, but it's not defined what happened in the other interval or with the entire interval. So this is the half interval definition. So if you want to expand this function in a Fourier series, you cannot, because you have to do it for the full period. That means you need either 0 to pi to 2 pi, or in this minus pi to pi in this region. What happened in this region? What happened to this function? Okay, so with that I'll so this I will discuss with an example. So let's say one function is defined. So these are always known as half range series. So that means 0 to pi, the definition is given. So you have to extend, or you have to extrapolate to minus pi to pi, depending on. So there are different conditions on that. We'll discuss that, of course. So so for example, it's the same or slightly different definition is given. So the definition is given for the 0 to pi, but this is in a different way. So this function f of x is defined as a x for 0 to x pi by 2, and here there is no discontinuity, and this is pi by 2 x pi. So that means in this region, so this is your, let's say, pi by 2, and this is your pi. So that means so this, let's say, pi by 2. So this is the function. So this is the function according to this, or this is the plot according to this definition. This is your x. So in this range, the function is given from this to 5. Now, what happened to this function to the other interval, like when you go for negative side or minus pi to pi to make it a 2 pi interval. So let's say I want to know this part. So in this direction, nothing is said actually. Nothing is defined, right? So you can just take this advantage that this function is in this region. This is x. So now if you put x is equal to minus x, so what will happen? This will be like this, right? And then you have, of course, this is a constant. So if you take extent like this, so this is minus pi by 2. So and this is minus pi. So in this region, you just extend this part. And now see what is the behavior of this function. This is a even function or odd function. X itself even function or odd function. X fx f of x is equal to x, f of minus x is equal to minus x, right? So this is an odd function. Odd function. Now, if you know that your function is odd, or maybe sometime it could be even function. So like odd or even, if you know, then what happens to your Fourier series? Let's see. So a0 by 2 plus an cos, sorry, summation an cos nx plus bn sin nx. So in this range, in this definition, we calculate an and bn, right? So how do we calculate? So let's say minus pi to pi 1 by pi fx cos nx dx, and this is 1 by pi minus pi to pi fx sin nx dx. Now see, fx is, in this case, let's say fx is odd. So if x is odd, then what about this product? Because cos nx is odd or even?
Both the product is odd, sir, but cost is even.
Cos is even, but this product will be odd. Now, if you have an odd function and you want to integrate minus pi to pi, what will happen?
0.
It will be 0. Then an will come as 0. Then you will get bn not equal to 0. That means if your if you are sure that your function is odd, then right away, without doing any calculation, you just say this is 0, and only aim will be to calculate bn. Similarly, if fx is even, then the opposite is true. That means an not equal to 0, bn is equal to 0, right? So this is the uh, uh, concept you can use whenever doing mainly this half range series. This is for full range also. Sometimes you can uh, identify the whether the function is even or odd, right? Then it is easier for you. Okay, so now now with this basic understanding, as we understand that this function, in this case, this function is this function is odd, right? uh, no, this function is odd. That means uh, this function is, if it is odd function, so so if it is, so again I'll just recapitulate. If fx is odd, then what will happen to a1, to b1? If fx is odd,
Sir, n equal to 0, bn not equal to 0.
bn not equal to, or an is equal to 0, and opposite is true for this is even. Even के लिए ये उल्टा हो, opposite होगा. So in our case this function is odd, right? That means we will have n is equal to 0 and bn not equal to 0. That means our aim will be to find bn from this for this case. Now, so for finding bn, 1 by pi fx sin nx dx, this is minus pi to pi, because according to this formula. So how I can write minus pi, so this will be, so what you will be, so if again another thing is that if your function is uh, if it is an odd function, then this will be an even function, right? This product, something is wrong, or this is odd, odd even. Yes. So something we did wrong in that last analysis. See, किसी ने जीरो बोल दिया इसको, मैंने इसको मान भी लिया. So what happened if your function minus pi to pi, so let's say you have a function, let's say gx dx, तो ये जीरो कब होगा? gx is even. If gx is even, what will happen to this?
Sir, 0.
इवन होगा तो जीरो होगा. क्यों? आप इसको प्लॉट करके भी देख सकते हो. So let's say this is your minus pi to pi. So in this case, okay, this is, if this is even, then this is your just a minute, sine is odd or even. So Uh, if I integrate this function, how much I should get? This much. So this area, this is negative positive. So this is a even function or odd function? Hmm? This is a odd function. So if I do the integration, how much should I get?
0.
Hmm?
0.
So, if my gx is, so this is odd function, right?
Yes, sir.
So then if you have a even function, so let's say even function, for example, cos mm,
Sine function.
hmm? Sine function is odd or even?
Cosine.
Sir, even.
Cosine function.
Cosine function is even, no sir.
एक मिनट इसका अगर cos का मैं कहाँ पे ड्रॉ करूँ, एक मिनट so for this is this function is odd, right? तो इसके लिए ये 0 हो रहा है, right? That means if this is odd, let's say do it for odd, so I will get 0, right? If this function is odd. Now if this function is even, that means if I have a function, so I have a function like this is pi by 2, 0 positive 1. So this will be something like that. So your cos function will be like this, I think, right? This will be 0, this is pi by 2, 0 pi by 2, yes, something like that. So now if your function is even, so let's say gx is even, so what will happen? So this will be cos function, something like this, right? So gx is, let's say it is even, so what it will happen, it if you see, but I can give you more prominent, right, kind of rectifier. So let's say you have something like that within this interval, so it is kind of sine wave with rectified. So so this function in minus pi to pi, how much it will be? So this will, if you see, so this will be twice of one interval. So if you know this 0 to interval, so twice of 0 to pi gx dx. So this is so that means if you know one interval only, right, and you know whether the function is even or odd, you can actually do the analysis. This is the actual idea. So in this case, now again I come to this fact: if fx is odd, that means fx is odd. So what happened? Ek minute. So we understood this one. Now come to that functional, because someone made a mess. Okay, confusion कर दिया. An is equal to 1 by pi minus pi to pi fx cos nx dx. Now if this is odd, so odd, or this is even, odd even, this is an odd function, right? So even function, uh, odd and even, this is an overall odd function. This is, if it is odd, the entire thing is odd, and then it will be 0, right? That means bn not equal to 0. So this is the case, and bn is equal to minus pi to pi fx sin nx dx. This will be, so if this is even, that means the function is even. This is what? This is
Again, what,
odd,
na, sir?
odd. So this is 0. That means an not equal to 0, because that will be other way around. So that means if your function is odd, then your an is 0, bn not equal to 0. If your function is even, then your bn is 0, an not equal to 0. That means always you will get only one component, either an or bn. Okay, so that means in this case, if x is odd, that means an is equal to 0 and bn will not be 0, but you can write this bn not equal to 0, that means it will be twice of that interval. So what I can write, because this is now odd, and odd, it will be even function. So if it is even function within this interval, then means I can write 0 to pi, twice of 0 to pi ff dx sin nx dx. Is this understandable? So this is the point I wanted to highlight. For if it is odd, then you can just write twice by pi 0 to pi fx sin nx dx for odd cases. That means, and I know within this interval, this is my definition, because this definition is given within 0 to pi only. That means in one interval. This interval, you know what is fx. You don't have to write your function for the minus 0 to minus pi. If you know the property of the function, whether it is odd or even, then you can extend it and you can get the value. Is this understandable at this point? So this is from the concept of that to product of two even function or odd even function, or even function, or odd function. Okay, so if this is the case, so I know what is how to calculate bn, and so using this definition you can calculate bn. So what is bn? So what is your bn is nothing but 2 by pi 0 to, again it has some interval, pi by 2 fx actually this equal sign should not be there. With this function there is a change, it's not continuous. So minus pi to pi minus pi to pi fx sine nx dx. So this is the thing. So now you know the values of fx in this range. In this range, this is the value. In this range, this is the value. So if you put it and you can do the analysis. So you can calculate the uh, series. So this series will be in terms of sine function, right? Because Bn is there, so all the sine basis or sine functions will be there. So, so you just complete it by yourself. This integration, these two integrations you have to do to find out the Bn values, and then you know the answer. Okay, so this is the case. Now, if your function is even, then you can do the other way, and that means you can calculate the an and you can just bn will be 0 for your that case, means where you don't know minus pi to 0 or in this minus interval or half interval. Okay, so this is same thing. Similarly, you can show that if your function is if the function if fx is even, then what will happen? If this is even, then your bn is going to 0, and an you can show that this is 2 by pi 0 to pi fx cos nx dx. So this is for if the function is even, then this is 0 and this is not equal to 0, and you can calculate the value of your function within this uh, interval, or put you know what is the value of your function within this interval. So this is all about your function which is given in half range. It's not given in the full range. Sometimes it may happen, for example, that it's difficult to identify. Uh, for example, uh, let's say I'll delete this, and then I have some other function. For example, I'll, you have, for example, let's say one function is given in this interval, let's say 0 to pi. So this is 1. That means f of x is defined 1 0. This is in the interval x pi Okay, this is given in the, okay, this is in the pi by 2 and this is 0. Okay, this is pi by 2 and this is 0. That means this, this and this. So this is pi. And then this 0 x pi. So in this case, in this case, these are the numbers, so you cannot decide actually whether it is even, odd, or something else. So you can actually, then you have to this, or you have to take that, okay, if the function is even, or if the function or this function behaves as an even function, then what will happen? So I'll ask you to do it. Let's take or consider fx as even function. So even function, if I want to consider the even function, then what will happen to the next half? So what will be the, so this is your x, this is f of x. So if I consider it, so this is your 0, this is in 1/2 pi. I want to get in this direction. So what will happen? So you have to make it even. That means you have to take it like this, make a equal or similar replica of this, if it is a even function. From the plot I can see. So you have to extend the function like this in this direction, and then if it is even, then your an will be, an will be 2 by l minus, sorry, 0 to pi fx cos nx dx, right? And bn will be 0. So you do this for even and consider fx as odd, then plot it and find the series. So so this is one case and this is another case. So that means if you can identify from here, then you can consider both the cases, if it is odd function or if it is a, sorry, even function or odd function. Depending on that, your series will be different. So you just check it, what series you get. Okay, so I'll stop here and we'll continue in the next week. Okay, and I'll ask you, so you just go through the ML boss book. So this is taking most of the analysis from there. Okay, okay then. So thank you.